So good afternoon to all of you. So we're again here for the third session, for the fifth session of this FDP and second session for today's in this FDP on IoT. So this session will be led by Mr. Mrityunjay Kumar. So and the session will be on exploring IoT sync for IoT applications. So I would just like to give you a brief introduction of Mr. Mrityunjay Kumar. He is the co-founder and CEO of Sync Grid LLP, which develops and manufactures electronics embedded products since 2017. And under SyncGrid, he also provides technical consultation as well as R&D supports to B2B market. He's 2016 batch graduate from NSIT, Netaji Subhas Institute of Technology, now becomes NSUT in Electronics and Communication Engineering branch. Before starting his startup, he worked for industry in Android development, IoT, and embedded sector for companies like Indian Railways, Texas Instrument, Tata Power, etc. So we welcome you, sir, for your lecture in our FDP.
Thank you, Naman. Thank you for this opportunity for sharing my experience over here. And as mentioned in the schedule over here, we are basically going to get some hands-on experience on some embedded devices. Like, so whenever we talk of IoT, so we usually talk protocols, we talk of some hardware, and those hardwares are sometimes very costly and
Sir, your voice is not clear actually. Earlier it was good, but right now it is not coming in proper way.
Am I audible now? Hello. Hello.
Yes, sir.
Now it's clear. Voice is clear. Is the voice is clear?
Yes, sir. Yes, sir.
Yeah.
Now it's better.
So, yeah. So when we talk of IoT, usually when we say that we are going to have this much billions of devices in the market in such many of this much of time by 2020, by 2025. So the large portion of those segment of units are basically small embedded device which is low powered and working in various products of day-to-day life or day-to-day data gathering units, day-to-day execution and actuation units placed at various places. So when we talk of such units, where we need to basically make those units by a small embedded system, and these systems are powered by some controllers and some NICs, network interface cards, which basically supports our concept of IoT. But what IoT exactly is, we already have this much of sessions gone in this FDP program. So we all know that when we talk of IoT as such, then we term it as the Internet of Things. So usually it's the perception that Internet of Things means something that is really connected with World Wide Web. So for example, if you have internet, so-called ISP internet, by ISP I mean when you have something like internet connection providing some, like Airtel is providing you internet, so it is called internet service provider, that is your ISP, or some Geo maybe. So the point over here is, when we talk of IoT, we usually relate that internet with the ISP, World Wide Web only, but that is not the all part. It is subset of it, but it's not the everything related to the set of IoT. So when we talk of building a system, when someone asks in the market that we want to deploy a system, we want to basically, for example, we are in the domain of home automations with the Tata Power for their uh, uh, household and as well as industrial product data gathering of their basically energy stamp, power stamp, power consumption stamps of the devices, and how that device is working, how to control that device on the time basis schedule. And to do so, we don't always need internet as such to be available. And in India or in the many countries, having internet all the time is also not possible. Like 365 days, 24/7, it is not possible. So the whole idea is we have to make our system such that the devices, the small devices, can basically work together for a greater cause. For example, if I have my AC, and that AC is basically uh, measuring a temperature. So why do I need to place other sensors of temperature measuring units in other devices? Maybe some fan units, maybe some temperature displaying unit in the clock or something. So if you have one sensor placed in your vicinity and in your environment, why do you need to populate those sensors at every places? You can ask that device to basically provide you a subset of sensor that it got to just provide that data, and you can use it over here. So this is also a kind of net formed by the devices. And if we have this net and being communicated to some other nets, for example, let's suppose if there's another network in some other subset, maybe in the different uh, factory, side by side factory, if they got some material that is the input of material of this factory. So they have their own network, and I have my own network. Might be there is some different subnet, so I can just get the data from that subnet. So is this the Internet of Things? Is this the internet, so such that my device is communicating to different network, different subnet, and I'm just getting that data? So should we call this Internet of Things? Yes, it is the Internet of Things, and it not necessarily to be connected to the ISP. For example, we have some clients in the remote areas of Guwahati. They have a production of iron ores and aluminiums, and they produce in uh, Arunachal Pradesh and Guwahati region. They basically produce maximum part of it, and there is a problem with the internet over there frequently. So they need to store those data for subsequent amount of time to basically sync every day or every alternate date with the cloud of their production records and of their how the quality of the ore processing and things are like going over there. So the whole point is that first of all, there is internet. When we talk of it, it's just not just ISP, it has to be something with the ISP. Secondly, we want rather than having big devices, like it's good that Raspberry Pi is a very good when we talk of systems to embedded system to be deployed for IoT. It's really a good solution to have deploy Raspberry Pi, but that is not uh, feasible from the consumer point of view. That costing that basically portrayed, it is not a scalable model for every application. So even if we go for something like in the research process, for example, let's suppose we have a campus, and in the campus, around the campus, we want to just gather the soil moisture data, and maybe moisture data, maybe how the temperature is varying in chamber. So, and from that perspective, we basically want to actuate some different unit to basically cool down or basically heat it up, maybe according to the requirement. So in this scenario, basically what we want is a cheaper solution. So I have seen this thing, the schedule being shared. In this, we have seen that people are using ESP 826. Yes, if people can basically solve this solution with ESP 826, and as such, the security concern is not there. Since I'm within my network, I'm using this. So there is no need to basically use the Raspberry Pi. In Hindi we say, अगर जहाँ पे सुई से काम हो रहा है वहाँ पे तलवार क्यों use करनी? Like why we waste like so much of this monetary resource as well as the power consumption, power requirement for long time running of those such units in such scenarios. So over here I want to present a solution with some uh, embedded ICs, MCUs, that is being manufactured by various companies. So over here, I am just mentioning the ESP32, and it got so much of popularity in the open source, as you say, that it has just surpassed all the controllers and all the MCUs SoC in the market present at that time. It started way back in 2013-14 when I was in just college, and the first variant of ESP 826 and 8285 uh, came into the market. And we at that time we already had something like C3200 of the TI and some Nordic MCUs and some Realtek MCUs, SoCs. And what I mean by SoC is that with on the same fabrication of silicon, we have the MCU as well as the NIC, network interface card, maybe communicating via Bluetooth to the some gateway to the internet, maybe some Wi-Fi NIC and communicating to some gateway to the internet or some different network. So that this particular segment of ICs by Asterisk systems surpassed all the other commonly available SoCs available in the market for by its price, because its price was way too low than other MCUs and SoCs available at that time. And also the development part of it has very fast. So if some libraries, some support, something is needed, it is way too fast, and open source community is able to develop on this platform very fastly. So there were some security concerns as such when we talk of IoT, and especially if you want to deploy such things in the open domain to some network, and so people over there, so industrial network, when we talk of it is prone to many cross talks, and it is prone to many chattering units, for example, even if that is not required. But in the industrial standard and in the practice, many devices are being manufactured by the company such that it just keep on chattering. Like if we classify the devices based on these three units, so you will see that there are three kinds of devices you will see in the market. First of all, there will be a device agar mujhe jab zarurat hai. I hope everyone is comfortable in Hindi. If not, please let me know. I will just work on it. So there are three kinds of devices I can say. अगर like मेरे पास अगर कोई मेरे पास सेंसर है, मेरे पास कोई डाटा है, जब उसे जरूरत होगी तभी वो कम्युनिकेट करेगा सर्वर. This is the one kind of thing. There is no nothing like all time it is consuming the network. Though that network is not costing me anything if it is the subnet or it is a local network created by me using LAN, WAN or something. But if it is a paid network, then it is a matter. A second one is that it is basically give me the data only when the master asks me or if it is required. Otherwise, it will not send it. So one is the periodic, one is the on demand, and one is the some conditional parameter that you will set, that is a sniper kind of thing. If that particular thing happens, then it will just wake up from the deep sleep mode or light sleep mode, and then it will just do its work and then again go to the sleep. So these are the three qualities. So the first one is that when it is keep on continuously sending it, the chattering box kind of device. So if we go for the protocol and as a beginner, whenever someone starts, so they basically keep on overloading that network by keep on sending the data packets, keep on sending the some data that is not necessarily being changing. If, for example, temperature is not frequently changed, but if you keep on sending that kind of data, that then it is just a wastage of energy. I mean, until unless you that network is made by you, that will not cost you the network cost. But if that is being paid, then it will again cost you the costing on the network part. So when in this manner, when we see that there was a special need for the like we don't want to overload the industrial network because many devices are being communicated, various important SCADA data, maybe some other data being communicating from the inventory, ERP, and something. So we don't want to choke. But when we start with the IoT part, we don't think of these three kinds of parameters. We just think if the as a beginner, I mean say whosoever is, so if our employee is starting, so if he is a beginner, the main agenda of their goal was to just keep on sending the keep on making the system in sync, two system in sync. If this unit is getting the data, keep that unit updated continuously. So that is not the industrial approach part of it. And when we came across these things, so we will have to explore the various embedded system concepts that are very critical from deployment and application part of the IoT. For example, I want to save the battery, I want to save the power. So from the embedded side part of it, I should know what is a deep sleep mode, what is a light sleep mode. How can I basically set some conditions, set some interrupts, so that my main core CPU is in the sleep. But if something happens, then it wakes up the uh, basically main CPU if you have multiple cores. For example, if we talk of some TI ISCs of sub 1 gigahertz that is being used by Tata as such. But in that, the sensor part of it is made out of the main core of the communication as well as execution of the code. So that sensor part manipulation and checking is being done separately on the low power unit system. So if something happens to the sensor, as suppose temperature is increasing, so temperature is increasing and there is some threshold. What is interrupt? Interrupt is something, even if I got a signal, I will just wake up on something. But if you want to set some logic on the sensor part of it, some suppose some maybe slope of temperature like gradient, how fast and how slow that is that value is decreasing and increasing. So this kind of application, this kind of IoT application which manipulate the embedded firmware part of it to achieve a bigger goal. I want to save the battery. I want to make the system run from a coin cell to an ear. Like there are many devices that LoRaWAN ICs, like LoRa, and this board supports LoRa. I have not come to this board till now. I'm just explaining the application part of it, but that's the agenda. What agenda we are solving with using the cost-efficient MCUs, cost-efficient deployment of sensor part as well as in the industry part and the home automation part, in the home segment. So these all are the requirements. So there are two part of it. One part is how these kind of tools, how for example, if you get a need to discover it, you need to discover it in your sub level. You should the first time you should be able to uh, uh, pair the device to your network. Number one. Number two, you if that device is already paired in your network, you should be able to see it on where various devices that yes, this that device is basically system in your network. If you want to attach that device, if you want to pull that data, for example, if you want to pull the AC is in your network and it is being connected to your router, and if you want to pull that data, so that kind of discovery mechanism, how two devices know that yes, that this device is there. For example, if we have a Mac Air and if we have Mac devices or Apple devices, those devices are basically easily able to find each other and communicate to each other and send the file. And if you are in the Windows, then you have to know some technical detail how to basically transfer the files, how to basically detect that particular Mac ID device or that particular device is online or not. So these are kinds of the mechanism and that will come from the software part of this segment, and this that has uh, uh, that plays a very crucial role in the IoT domain. So what by the discovery I mean there are device discovery. There are different protocols. For example, UPnP, for example, MDNS, multicast DNS services that facilitate the discovery of the device within the network. For example, when you deploy some units for the research part of it, you want to deploy it, but you want to see if that device is like in deep sleep mode or wake up. If you wake up, you want to send some data, or if you want to do some firmware update part of it. So that thing basically required the embedded perspective only. So by not getting more into that and just getting back to the hardware and the application part of it, I like to introduce this board. I hope you are able to like see this page of mine on the shared screen. Is it visible? Hello, Namaste. Is it
Sir?
visible? My screen?
Yes, sir. Screen is visible, sir.
Yeah. This board was designed to facilitate the research work of it, the students, the research workers, for gathering the data, for gathering the high-speed data, for gathering the storing the data in some persistent memory and retrieving it back, or if that network is present, their LoRa unit is present, or some long-range units are present. So we want to basically use that NICs to basically communicate in the real time. Basically, this board try to explore the majority perspective of the IoT domain as such. For example, various kinds of and explore the various kinds of NIC. When we talk of the IoT, so traditionally, when someone starts the IoT part of it, they goes into the network, how network performs, how network basically work in the OSI model layer, and what is physical layer, then ascending order we go above, and how these kind of things works. But from application part of it, when someone tries to build an application, or someone tries to deploy an application, someone tries to basically deploy a solution, or for the research part, or for example home automation part, or for example to the industrial solutions, uh, they need to basically know the range of the physical media, physical this layer, or the communication network they are choosing for. So this board provides a variety of NICs that will be from the near field communication, for example NFC, to the very large range communication LoRa, to the medium range communication, that is Wi-Fi and BLE. To and in this part of it, and we go from the very short range to medium range to large range. So there are many applications that can only be developed by the near field communication or short ranges of such devices. And when we talk of medium range, then there are Wi-Fi and Bluetooth to support us. And this Bluetooth and Wi-Fi are more common with the user. Why? Because when we talk of the normal user behavior pattern and the devices they got to basically communicate with this embedded device or to the cloud, then we came across very few NICs. For example, my phone only support 2 or 3 NICs to communicate to the embedded device. That is Wi-Fi, BLE, and few phones support NFC. No one supports LoRa and LoRa communication or LoRa physical layer. So the units which are more popular with the devices that usually people play around, and they have the system. So we will find more and more IoT devices being built on that, because the main agenda of the devices is that communicate between the largely available segment. And what is the largely available segment right now? It is a Wi-Fi and BLE. That's why we see so much of the ICs and internet blogs and videos on these kind of NIC, Wi-Fi and BLE, because most of the users have that kind of interfaces available to their laptop and to their uh, phones. But when we talk of some industrial or large scale open network, then we have to go for the LoRa and LoRaWAN and LoRa communication. Sigfox, and these two are the two technologies which are not popular in India, because India came from some like colonization period, and then there is something our standard of ISM bands are more closely related to what the European standard and what is being followed in the Europe. And that is the reason why the LoRa communication and LoRaWAN is more popular over here, because these and more popular in the India, because our ISM band is in the sync with the European side, and it is being allowed in free ISM band to use such like 865 to 867 megahertz of band to be used by the LoRa is allowed, legal in India for the industrial as well as for the uh, personal use, as soon as still you basically follow their power dissipation and that kind of norms, you can use that. So that is why this in the terms of the range, this board provide this kind of physical medium to basically communicate and receive the data for the long range, for the short range, or for the near period. When we talk of the topology, for example, how when we create WSN, wireless sensor network, in in the sense from my this thing AC example. If I want that thing to basically all those NICs, for example, all those Bluetooth, or for example, all the Wi-Fi. Take the example of the Bluetooth. If I want all the Bluetooth NICs to communicate the data to a central unit, then to a single central unit, then that kind of topology we call uh, star topology. When we want in the Bluetooth 5, BLE 5.0, there is some mesh network that we can easily form for very low power and for long mesh kind of network, ad hoc kind of network. So in this board, you can also demonstrate the this part to various topologies of the wireless sensor network. And when it comes to the programming and debugging interfaces, so most commonly available interfaces in the market with this kind of environment are just serial. You have to go from line to line. You have to just print and check every statement. I'm talking in the till now I'm talking in the general sense to the all the SoCs available in the market by the Nordic, by the TI, by the Microchip, whatsoever. So in this system and those kind of system, when we compare the devices that come with the debugger, they are way too costly, and the debugger part of it is hard coupled with the system. So if you want to basically deploy that unit to some place, so you can't do that debugger part of it being attached to that and being deployed somewhere. It doesn't make sense. That the debugger part of it is not separate in the most of the MCUs. And if just for the debugging part, if you want to basically if you just stuck in somewhere, we will introduce some RTOS and real-time operating systems, how the crucial part of it, how that is in the sync with the networking and the execution and the power saving mode and all those kind of things. So over there, sometimes we came across a situation when we need to debug it. We need to debug why the device is not coming from the deep sleep mode, or why the device, if it is coming back to the deep sleep mode, why a particular register is not behaving in the way, or because whenever if something device basically some brownout reset occur, or if some device goes on some reset because of execution fault or something, then that particular register will again reinitialize, and you will not be able to fetch the last state of it until unless you basically prepare whole stack, the memory stack of it to be printed on the failure of that particular execution of the code, or you have a JTAG to basically stop that code at that particular moment whenever something is going wrong. And the most commonly available peripheral for the weather station and for the IR transmission and receiving, for gathering the room data, all those things are basically available on this board on board. And various provisions of connecting various kind of sensors, for example TS sensor, or for example any industrial sensor, those interfaces are available on this board on the right side part of it for various kind of communication. For example, if you want to do the if you want to produce some DAC output, or if you want to fetch the data, if you want to transmit the data. So all those pins are having various special functionality. PWMs are available on the pins, and the ADC part, ADC also is available on maximum pins. And so these kind of features are there. So main agenda of this board is to basically make the participant, the students or researchers or industrialists to be familiar with the maximum aspects of the IoT available in the market for the personal consumption in the terms of the technology, how it is progressing. So most of the things uh, we have to, for example, if you have to discover the device independently, that yes, device is Jacob, we need to need the MDNS part of it. We need to know the logging part of it. So this device provides a maximum among those subset in the open source domain. That's why we chose this particular board to be developed, and it is a fast prototyping board in the IoT segment on the cheapest MCU available in the market with this much kind of functionality. So this is a development board. When we talk of the deploying, we just need the central SoC of it, nothing else. You have to, for sure, you have to design your own PCB or board for that. If you want to reduce down the cost below the 400, 500 rupees, you just need this IC and your circuitry. But this is, as a whole, is a development board that provide you the all the various aspects, from the range to the various kind of power saving, various kind of uh, transmissions available in the this domain, IR transmission, basically CAN network, and all those things you can perform it over here. So luckily I got the 2 sessions to just explore and share my experience in this. So I basically distributed the 2 part of it, something like we will use it something. Today we will go into the maximum software part of it. And tomorrow we will just like the onboard titles and all those things. Tomorrow we will just basically see how this kind of device discovery help us to connect the Alexa part of it, how to basically trigger the Alexa. Is it necessary that our for basically running the our MCU or embedded system within my network, do I need to develop some remote execution serverless code on the uh, AWS IoT core, or maybe some Lambda service, or maybe something, or we can just make the Alexa communicate to our device within the subnet? Is it possible? And if it is possible, how that part is being done by the Alexa? How that is Alexa is discovering my device? Maybe my AC. I will also demonstrate how to control my AC and all those things. But how is it feasible that without running the Lambda service in the open source domain, how people basically execute their code, the Alexa basically communicate to their device by discovering it automatically? And on the other side, how these devices are basically communicating to the various IoT stack. What is how it is communicating to the some public subscribe model of MQTT, or how it is uh, communicating to the basically request response model of REST API. And what is the difference between device, and what is more suitable for the IoT segment part of it? When to use REST APIs and when to use the this public subscribe model of MQTT or POAP as such. Like what is the differentiation part of what is the packet header overload of the MQTT? Why MQTT became so popular in the this IoT domain and embedded part of it and the low power segment part of it? Then the REST API that is always been prevalent from 90s in the various section, from the since the inception of the uh, internet. The maximum web services like banking or some these kind of services are deployed around the REST API, push pull get request and this kind of things. Then why that part is not suitable for the our low power embedded hardware? How what is when this MPT requirement came arise, like if for the solution part of it, that when we talk of MPPT, and suppose I want to communicate to the server just for a small data. So the overhead of the HTTP as such or TCP communication as such, that there are header that is, so we all know that different basic difference between UDP and TCP. And for to make the TCP more reliable communication, uh, just let me know if some statement is confusing or I'm not making myself clear on that statement of CCP FDP or something. I will elaborate that. Just in case, I suppose everyone is in sync with me. Just in case you guys are not comfortable with any statement or find any statement wrong, just let me know. I will just make myself clear. So when we talk of TCP, we want that communication to be basically uh, um foolproof, that it happened. It is the double cross check that packet is received or not. But that comes with some overhead. And for example, if you trying to get a image or trying image by image, JPG image or PNG image, that kind of cross check and checking that this packet is came and that is okay, that came with the overhead, but that part is okay. But if I load a website, I just put a REST API hit request and I receive that. In that kind of communication, that kind of cross checking is prevalent. But when we talk of the devices, when my data is in the bytes, and if my, like in the my HTTP, when I basically go with the TCP part of it, and this the overhead is 4 megabytes and something on the header part, and I'm basically paying for that kind of network. If you see the pricing part of the IoT devices or some IoT servers, web services like AWS or Watson or something, they are charging you on the basis of how much consumption of the network you are doing. Okay, so if I develop some device and for every kind of request, if I am making some overhead and if I am making that communication just for the bytes of data, for just basically posting the temperature as per se, then that kind of overhead will cost me a lot. It will not prevalent in the near time, but they are working the idea behind the working of these kind of web services, and the money making point of it, that they make it on the network. And when we see the overall like the users of the how much you do the consumption till the year or second year, or then you will see that you made a lot of like wastage in terms of the three kind of devices I already talked. That if you don't need to basically send the data, even then you are sending the data, keep on sending the data, that kind of development on the paid network, on the paid services, will cost you a lot. So today we will go with the software part of it, how to getting started with this board, how this board help us to basically facilitate a development. What are the different development that is more prevalent in the open source domain? Uh, you all must have heard of the Arduino. So how that Arduino framework is being consumed in this, and in the background, how the RTOS part is running. So when we talk of Arduino Nano or this kind of segment of the devices, they have the C compiler in the end, and they consumes the firmware level at the function, or you can say the device this register level. If you see if I hope most of you are already comfortable with Arduino Nano and this kind of environment. So when we classify the embedded systems, so when we write the firmware part of it, though, there are 2-3 kinds of level that we came across. So first of all, there is an assembly language where you write everything in by looking at from register to register, getting a accumulator and those kind of things. Then that is what is more prevalent is second one is the register kind of development. What is more prevalent in the Arduino AVR segment and this Arduino environment as such, when it all started with the open IDE and open source firmware development and hardware development of the Arduino. They basically use the AVR GCC for the device register level of programming. Then came when system got bigger, some Cortex series of ICs appeared. So they basically in some megahertz they work full. I can also classify with the clock basically what region they basically operate in the assembly in the, and how as your system got bigger and complex, you need on the firmware's development part of it, you need more sophistication, more easy to use APIs or more easy to use function. So this is how the overall abstraction layer basically created. So when we go on with in our curriculum or in our college times, we started with the research part of it with the assembly. Then we gone to the register level programming part of it. So that register level programming part of it basically consumed the name of the register that is being translated to the address memory mapping of that particular device. Then came something known as this thing. Function API part of it. For example, if you see the Cortex series, so the Cortex series, and you will see the big APIs, STM controllers. If you see the TIVA series of the controller, you will see the function being available to you. More complex function with proper documentation. You just call those functions. Those functions in the background do the for a single register setting, do the multiple setting at various places and get the thing work. So as the system get complex and complex, the more sophistication is needed. So the development companies, development software engineers basically provide the APIs part of it. When we grow somewhat more, when system got more complex, so whatever SOCs and we are talking of in the IoT domain, from the NRF series to the ESP32 series to the TIVA series to the STM series, they all basically are complex and they need easier APIs to even perform the very simple task. But if we perform that task in the register level, we have to do the many settings and many controlling of that. So especially in the embedded domain, when we talk of in the Cortex series, we get the APIs. But when complexity get even more, then we need OS. And for the embedded for the embedded part of it, there is a specialized OS termed as RTOS. That is the real-time OS. How that RTOS is being different, I will just come to in this subsequent pages. So that RTOS basically make even things more easier. For example, this particular IC is a dual core IC. You have two cores, and suppose your execution of Wi-Fi, BLE, and LoRa is executed in the single core, first core, and you want your code execution, your code manipulation for some statistical analysis, some averaging or something in the second core. Then you want to communicate these two cores in a such a way that they work in sync. And if you see from the execution part of it in the assembly, it is way too difficult. What is the shared memory spaces, how shared memory is being working. So this kind of thing doing in the assembly is way too difficult. You have to basically allocate a common memory, and then you will use that memory for the sharing of the data or commands, and it is way too difficult to be implemented, as well as product development time and time to market is concerned. Then second approach is we can use the APIs. That higher level functions being available to us by the company, and we can use that APIs. Yes, it is a possible solution, and I will just also explore, mention you in the subsequent pages or slides, you can say, pages, basically web pages, that how these higher APIs are more prevalent in the advanced user kind of environment. Then we came across RTOS. So the maximum development of this these kind of devices, when your complexity got increased, is done in the RTOS, and this device uses the free RTOS and the Arduino framework. That the framework what we are usually aware of, or we are comfortable with. For example, this kind of simple function, that simple device, digital read or analog read, that we all know and we are all comfortable with. Just let me know if I am making some claim that is not true, and if I want to explain some, just let me know. I'm just taking it for like granted, this kind of knowledge. So I will just explore if you need. So these kind of functions are which are easy to use to us in complex systems. These simple statements are being translated to some OS RTOS related task function, and that task function is calling that higher APIs to basic, for example, to get the analog value. So I will just initiate this analog read command, That analog read command will run in the task in the RTOS, and that task is being translated to the higher API function call. That function call will get the register level data and again return the data back, and that data will be received on the single variable, whatever we define. So, this is the simple. This is a simple Arduino framework covering up of the complexity of RTOS and this thing, higher API. And this particular Arduino framework of it provide us and facilitates a fast development, reducing the complexity part of it, how this Bluetooth and Wi-Fi switching is being done, same antenna being shared, how data is. So all these complexities are handled by that RTOS, and we are simply making some function calls to perform that function. So we will get to that in more detail, like how that Wi-Fi part of it is being triggering the system, how what are the different modes of it. So all the examples are ready with me. So as soon as we will get into that part of it, I will just share those example and working part of it also. So when we talk of this board, so we have to start with some like ID part of it. So Arduino, what I already told, that Arduino framework, when we want to use that simple analog read, analog write, digital read, digital write, we are basically facilitated by the open source community, and we want to use the Arduino framework. For the using the Arduino framework in the ESP32 environment, we can use these two ID. One is the Arduino ID, which is we all know, and which is commonly available from the Arduino website, arduino.cc website. And after just installing, so I will just also show you. So after installing the Arduino ID from their website, we have to just just put that additional board link over here and press OK. Thereafter, you will see that board. Just a second. So you will just add that particular board from the tools board manager, and add the ESP32 system. And in the tools now, you will just see that this ESP32 dev board to be selected, and after selecting it, you will just easily just simply write the code and compile the code. I will just show you an example just to get into the practical part of it, so that we will again discuss some technical aspects and get into that. So I would just like to share you the simple web server. So like connecting it to the router and getting the values from the ESP32. So this is how we will this is all in the agenda, that what is wireless device role, topology of the network, device differences between the unicast, broadcast, and multicast, REST APIs, MQTT, what is WebSocket, what is QA, what is network discovery, what is UPnP, MDNS, securing flash, Bluetooth communication. So these all the things that is the crucial part of the IoT development, firmware development, device development, security analysis, and these all things require can be like demonstrated on this environment and on this board, and how these things are basically facilitate us to basically make the up-to-date industrial level products from this, and this is the pretty much used in many industrial applications, this particular ICs. And if you go with the this just a second. If you go with the data sheet of it, you will see that there are so many things that can be performed on it, from the PWM tag to the higher DSP calculations, floating point calculations. So all those are the embedded part of it. So in the this internet and IoT part of it, these all the things that can be achieved on this board, and those codes are available to you on this repository, and that will also the content part of it also will available to you on this website also. Tomorrow we will also elaborate the various or running codes from that repository from over here, and how we can basically interface some physical devices and get the data into it, into the cloud, into the Bluetooth, into your phone via Bluetooth or some other medium. How to communicate that data between two LoRa. This one board will become the client part of it. One board will become the server part of it, and how these two boards can communicate to each other from in the range of, you can say, 1.5 kilometer, 2 kilometer. And if you have good antenna, and if you have freshnel zones, like if your antenna is placed at some higher place, so in the open and rural regions you can achieve the range of 5 to 6 to people claims the 8 kilometer range. But I've seen in the open region you can easily get 3 to 4 kilometer of range, and in the metropolitan city you can very easily get the range of 600 meters to 1.8 kilometers, depending upon how the shadow regions are prevalent over there. So those codes are in that repository. I will again elaborate those codes one by one, and these all are the scope of the our exploration, and these codes are available over there, and we will just go it one by one. So just getting to the demo part of it for a single example, just a second. I will just so this was made by one of the student at IIT Jammu workshop. So, and this system is made solely by that student, maybe second year or third year student. And over here, what we are seeing that we have some onboard uh, peripherals available to us, and there are various kinds of communication that can be achieved uh, with a wireless sensor, and there are different kinds of rules. I will just come to that. So we have some station wireless station clients. What I mean by that, that you are connected to a router, and that router is your access point, and your device, your ESP32, your IOTA SIM board is a basically server of it. And for example, so this device is being communicated to some router, and you have your laptop, and that laptop is basically accessing it via router to this. So this is your access point, and this is your station. So in this way, your laptop is basically communicating to this device, and how long your this Wi-Fi communication can basically go. You can uh, basically expand that kind of network or range of device. From there you can basically fetch the data. So over here you can see this is the sensor, that is BME sensor, that is giving us the humidity, the temperature, the altitude, the pressure, and we are not sending this data to any so-called cloud for basically making it available to public IP. We basically are, so this over above that I have ISP, and we are doing it within our network. So our router is basically access point, and this device, this particular IC will be the station, and our laptop is accessing this device in a station mode via router. Okay, so over here you can see that each temperature, pressure, and humidity, altitude, all these values are from the real sensor and the real time. So there are some sampling interval. That's why we are getting like I just restart it, refresh it. So you will see that every sometime you will see the refreshing part of it, and that is being done, and that refreshing is basically done in the JavaScript part of it. So when you basically hit the device in the station mode, that device will basically return the JavaScript files and uh, other content from its SPIFS basically file system, basically Flash, to the your browser, and that browser will basically, after receiving that library, you start the refreshing part of it, fetching the data, and it will again refresh, and that kind of refreshing is doing over here. And these all data, if I just put so if I just change the camera and will just show you. Yeah. So this is the device, and I've just communicated this via USB, and over here I have the sensor. So it is fetching this sensor value, okay, and this is being connected to my router, and on every data refresh you will see the blinking of an LED. So if whenever that refreshing part of it is being done, that LED will blink, and that will again send the another data. If I just try to like increase the temperature of the sensor, so you will see a slight rising in the temperature of it, and that is going up. Okay, so so you can see that we are sending it in the web server mode. Now, so how we wrote this code? If you see the example of it, so these are very basic header available for various units, Wi-Fi, some MDNS like device discovery and all those things. And I'm just calling those headers for including that and using that in the code later on. So uh, after uh, calling this headers, I'm just using that for the initiation of that making an instance, or basically instantiating the making an object of that particular class, and decide giving the various variable names, and in that variable I will just basically call this two updates. Basically, I will call this over here you can see I will just call this you can just view the data, and after doing that and after doing those averaging part of the data, getting the multiple samples, what I will do, I will just use normal HTML template that we use from the skill day, and I will just place those uh, variables over here to basically uh, update it, and on the refreshing of it, and those refreshing will basically generate this kind of graph. Okay, so it is just an example of it, like how onboard on maximum weather switching the temperature and humidity and this kind of sensor data that we are needed. We basically, this is the onboard sensor available to this board, and you can, and this is also digital grid sensor, which is very prevalent in PCs or various devices. So you can just get that data from that, and you will just use it to basically render it. And you can see that even though it is running the FreeRTOS, but we are not seeing the complexity of the FreeRTOS over here. So in the background, if I have to see that what is going in the background, so you can see there's something like this is going on, that some task is being created, some after the execution part of it is being deleted, and again it is being created, and how much stack is being required to basically run that task. So different few tasks are very simple and doesn't need that much memory space or stack size. But few tasks are such that they need some stack, because while doing the calculation, they need some stack or memory to basically perform those actions. So those all things that is that is going on in the background. But if you see this our code, we are not getting into that complexity part of it. It is being taken care by the our Arduino framework. So when we talk of the Arduino framework, this kind of leveraging in the terms of concrete development we are getting, and we can also perform this with the platform IO, like platform IO and Arduino IDE are the two IDEs, and so we can also push this kind of code compilation and the code coding part of it from the platform IO, and you can see some. I will also demonstrate this how to use platform IO, and this platform IO is the more prevalent in the open source domain and for the bigger projects. So if you want to, if you are starting with the students or you come from bigger projects, where you are sure that there are multiple CPU files and many files are being developed, and as soon as your code part of it will start growing. In the Arduino IDE, you will see that for the bigger code, for the larger volume of code, it is difficult to basically debug it or to find the exact reason or to include some other file code in some other file. Like if you want to import a function from particular INO file to some other INO file, you just want to call it. Sometimes Arduino IDE will say something like you are getting that this is not this prototype is not available even after you have prototype in the main header. So there are these kinds of errors that appear, and for the bigger code and for the very big embedded projects, Arduino framework is being used, but Arduino IDE is not that much popular in the open source community. So new alternative that appeared in the last 2-3 years is platform IO, and this is very good for large scale projects and for the bigger projects. So how this works, I will just demonstrate it. So let's take an example of so this particular project is written in the platform IO. I will just open it in the platform VS Code Studio. And why using the platform IO is more prevalent in the bigger project, and this IoT kind of ID is more prevalent. I will show you. For example, if you see that I have a code, simple code that I have written. So sometimes what happens is that if you when trying to compile a code or trying to run a code, you will see that library is being updated and is giving you error. You want a particular version of it. You don't want that another version, the updated version, because you have run that code, let's suppose 6-7 months back, and there's the implement in that library, but you don't want that library version to be created. So the platform I will give you the facility or provide you an opportunity to basically mention that particular uh, version in the dependency file. So whenever you will compile, no matter when, after a year or somewhat more, that particular version is only downloaded. Suppose you have the code, you have the link to the this Arduino library. So you just mention that GitHub link only, and it will with respect to every project. It is not something common. Just suppose you made some changes in some library, and that is common to all the projects. So that will become difficult to manage and to basically find what is error coming in second project, but I can first one. So this kind of platform IO and kind of development basically helps to basically maintain those library part of it, and also you have there are different kinds of variables. So suppose if you are not using the Wi-Fi, you just want it to for the better calculation and something, then you can just utilize the fun 160 megahertz or even more power of it by disabling that kind of uh, Wi-Fi consumption or inputs needed by the Wi-Fi or Bluetooth to run if you are not using that. So this much powerful CPU you have, and there are different parameters that you can use. So if you go with the platform IO, you get these kinds of benefits. For example, if you see in this, if I am using the main.cpp, and if you want to call some library or call some driver, so I can mention it over here and call it like a normal C++ development we call it, and all the code is same like INO. It's just the extension that is different. That's all. So even if you see the how the ID is basically written for the execution of it, you will see that that ISO code is again translated to CPP files, and a single CPP file is being made and all those things. But over here you have the customized choice, the way you want to call it and they will want to basically. So this particular code also available through the code base. You can basically compile it and push it, and you can basically send all kind of remote data, and you can just log it like who is using what system, when is being triggered, when TV is being triggered, and you can basically log that kind of user pattern by when that initiation was done. For example, when TV is on, when off button is pressed. For example, if you want to basically override some IR transmission, you basically don't want to use the basically AC remote, and you want to use this kind of platform to override that functionality. So you can easily use this kind of code or development kit to basically initiating some logic from your code and then turning the system on, off, AC or something. So these are the common things. So if you see the basic of the RTOS, so basically it provides you the operating system functionality to the embedded device, and your code, our code, whatever we have written in the this platform, that simplicity is being maintained by the Arduino framework by calling those RTOS functions in the background, and we are not exposed to it. We are using simple singular.print function. We are using simple digital read, digital write function, setup function, and in the background, that particular framework is reducing our this code inferences from Arduino framework to the something that is needed by the device. So when I talk of this code schematic, so this is the open source design of the schematic that is being available for the development of it, and you can see how this is being made, what are the corrections available on the external pins, and what is the OLED connection pins, what is the LoRa communication pins. By the way, in the GPS code, you will see the all the mapping of the pin pinouts available to you on the cloud on what is available. For example, if you want to use the I2C and SCL part of it, what you will need to do if you want to use the Europe and all these kind of pinouts are available in this uh, template only. So you need not to basically refer to the schematic every time. So so they so this is the schematic available to us, and I'll just again show you some more codes and how it is being used by us. So these all codes are available on the repo of this unit. So you need to find the grid.com website. Here all these codes and documentation are available. And some more information about the availability and buying available on the our store. Then you can see this board over here, and you can basically explore it detail or the availability and purchasing part of it from this link or all the gem. This is available on Gen 2. So when we talk of the Wi-Fi part of it, so there are, for example, we want to control the device LED from the web server. So again, in this scenario, our system is a Wi-Fi client, and we want basically in this system we want our ESP to act in the station mode, and we will access it by the accessing point of the router. So we'll just double click on the link and I will just show you how it is being going on and why it when it will work. For example, it will work in the local network. But what will suppose you want to access the parameter of the unit from the outside ISP. For example, you have something in your Wi-Fi and you just started IS phone network by installing the Wi-Fi and the mobile network, and you want to accept that value, go with that work, and if not, why it is not working. And if you want to make it work, then how you will basically use or configure your system to do so. So this is a simple client example. It is also available on the this method. So you can access that code here too. I will just also open it from uh, so over here you can see the code. So over here I'm using this that server to control and I'm using this code. If you go to the this particular IOTA async and from the you go to the elaborate how I am using this code. And you see that I'm just simply making a web server, and by the web server in the station mode at some port, and that port is 80. So what is happening? Uh, I'll just do that. So our device over here is in access point mode. Uh, Router is in access point mode, and our is actually in station mode. And our laptop is basically accessing this particular device on the port 80. Okay, and that particular this device will return a HTML depending upon various when I'm clicking something. So that HTML is being returned to this. So if I press uh, certain button on it and give a command, so it will then go via router to the this router sync, and that particular LED will be. So I'll just demonstrate it, and then I will see when you are outside the ISP, like accessing, you want to access this from via ISP. What is the bottleneck over here? What is the firewall bottleneck over here? How you can use tunnels, how you can access it with the help of the tunnel or with the help of the something called demilitarized zone. It's something army and kind of terminology. But how you can use this demilitarized zone, that is the configuration within the router, or how you can use the firewall of it, or how you can use the tunnel. So these all are the technologies being available to us to basically, if you have a college, have a firewall, and you want basically some data being uploaded to your computer or to server within your college premise, then you need this kind of technical settings to be done or to be facilitated to access your device by your router, or if you have another device over there and you want to just push that data to your server or to your laptop. So you need this DNS and tunnel kind of the device and the firewall settings to be made to do so. So over here, in this example, what I'm doing, I'm simply using my router to as an access point, and on via laptop I will just control it. And later on I will also show you different ways how you can export this device over the internet. But again, there is a caution that you only need to do so when your device is you are assured that whatever you are doing and your communication network is safe, like whatever protocol you are using, whatever server you are communicating with, who all can enter the network, and all those things. So when you are assured of that, you can perform this. So, in this example, you can see that after pushing that HTML code, over here we are getting some value HTML depending upon the REST command that is being generated by the JavaScript, that JavaScript HTML page that we have sent from this device. You can see. So that REST HTML request is received, the REST API request will just go into the certain function that will control the device by executing the firmware command of digital write. And if we get a L, so we will just write the digital write load. And over here, this client function, the server of it, the REST API server of it is being made by this statement, and this is being available, and this Wi-Fi client server is being made, and when you are connected to that particular network and IP is being allocated to you, then you can basically use that particular REST server to basically accept the connection from your browser. So your browser is basically getting it, and your browser on this get and these kind of get request, and depending upon these conditions, that whether H is received or L is received, your device will respond. So I will just push this code and show you this. So I will just change the port number to 11. So this device is Extensia toolchain powered. So this is another kind of architecture being popularly used, and this toolchain again are for the higher toolchain functions to GCC functions to basically convert the code to the register level, and the all compilations in that reference. So that is what is very So you see the screen, we have two again, we can make it fancy, we can add the CSS, various things to make it look nice. But again, and it is simple request that is being made. And if we just send this patch, let's see on the camera part of it, that is also shared. This here, you can see on making this request that device is responding in real time in milliseconds, and that device is basically responding to the code. So what we did in the code is client, and we are receiving that and the HTML part of it. So what we did today is we explored the Wi-Fi part, and how the embedded system from the pre-outpost part of it, from the firmware part of it, is looking to it. And we have only used point-to-point communication as of now, but these devices also support the mesh networking. So I will also demonstrate it tomorrow, and I will also use some IoT stack and server to basically demonstrate these other technologies, the LoRa, the socket, and the UDP. So by that I received the two session. So I will just continue on this tomorrow, and I will use this demonstration, how you can use the cryptographic part of it, how you connect with the cloud, and the laptop. So we already covered the other part, and we will just tomorrow the maximum part of it will be on the protocol and how we implement it with our own server, our own created stack on the cloud, how we create the stack, what is the commonly available stack, how we use Docker. The simple command. Now we will not get into the details. We will just share. I will share some resources that how you can create your own data collecting aggregating server, and use this PLE communication communication demonstration and create over there update on the firmware and how. So all these things I will just complete tomorrow from this part to this part. I have already shown the rest that is from the MPPT to it, network discovery, Bluetooth, and how Alexa we can make Alexa trigger. So I will take this all these things tomorrow, and you can ask any doubt if you have on today's session or how these things bend or if you want to basically update or speak on some topic or something if you want feedback. If you have any doubts, please ask. Since we are getting close to the deadline for so manager. Hello.
Yes, sir.
Yeah. So I think we are getting to 30 so
Yes.
can complete. If you know if there is any questions, any doubt or any thing that you want to follow, please.
Yeah, if anyone having any doubt, so one can ask to unmute himself or herself, or you may also write your query in the chat box. So we're waiting for 2 minutes. If you have any query or any doubt, so you just can discuss with sir.
Why synchronization is critical to the IoT? Synchronization is what sense? Data and like all the data are like sorry, I'm not getting your point. That it's because of the clock. What kind of synchronization are you talking about?
So, sir, I think there is no doubt, or if there will be any, so we can discuss in the next session as we have one another session with you, sir. So, thank you very much, sir, for giving a practical implementation and demonstration of IoT. So, thank you very much, sir. We will see you again in the next one more session. So, thank you very much, sir.
Thank you, sir. I will just go ahead tomorrow with the left part of.
Yes, sir. Yes, sir. Definitely, sir.
Yeah. Thank you, everyone.
Video here, and we will be back with video in the last.
Yes, sir.
Okay, so I'm stopping the video. Right. So, good afternoon, everyone. As we have completed one session, earlier session on different standards and protocols, And also my colleague Mr. Krishan has covered how to use ThinkSpeak Cloud and how we can send the basic values like temperature, humidity, gas, and the basic values how to send to the ThinkSpeak Cloud. Of course, there is some small disturbance in the internet connection, so we are not able to share the particular PPT. So just I want to go through this PPTs yesterday's just PPTs for 5 minutes. I will show how neatly the PPTs are arranged for the ThinkSpeak. I will show those PPTs and we will go for the today's topic. So today's topic is setting up Amazon Web Services Cloud with IoT platform. So yesterday you have seen that so many clouds are there. There is a ThinkSpeak cloud. There is something called UBI dots. There is something called Blink cloud is there. There's something called Adafruit cloud is there. There's something called Cygnus. So like that, there are so many user-friendly clouds are there. So, but other than these user-friendly clouds, there are some commercial clouds are there in the other side. Of course, these are user-friendly, very simple to store your information. But if you want to go for any complex analysis, these clouds are not sufficient for your complex analysis. So in that case, you should have to have at least one commercial cloud knowledge. That commercial cloud may be a AWS, that is Amazon Web Services, or it may be a Microsoft Azure, or it may be a IBM Bluemix, or it may be a Google Cloud Platform. So these are the four majorly used commercial clouds. So in that particular majorly used commercial clouds, today we are going to discuss about the Amazon Web Services. So as I promised before going to these Amazon Web Services, okay, so let me show you that these are the different PPTs that we missed yesterday, I think, ThinkSpeak Cloud. So these are clearly each and every step it is given over here. So you have to enter the URL thinkspeak.com and just click on the get started for free and fill your details over here, and next, after filling the details, it will ask for the MATLAB account if it is already exists, because this ThinkSpeak is a developed by the MATLAB, associated with the MATLAB people. So if you are already having the MATLAB account, no need to create a new account. So it will ask that whether it is your MATLAB account or is there any new account you want to create, something like that it will create. So that's why I'm checked out here. Use this email for the MathWorks account. So like that, once you created your email ID, you will get a mail. So you have to open your mail and click on that verify your mail. And after clicking on your verify your mail, this is my mail. So I got some message from service@mathworks.com. After that, I will click on the verify your email. After that, I'll just coming back to the ThinkSpeak here. This is a ThinkSpeak one. Coming back to the ThinkSpeak here and click on continue. So this is the way that I given each and every steps very, very clearly, and what is channel and how to create a new channel, how to create the each and every fields like temperature, humidity, light. Yesterday we have seen some fields. So how to create all the fields. So everything screenshot. I have taken the screenshot of each and every step, and I will explain everything in the things very, very clearly, like what is the maximum channels that you can, maximum fields that you can create, and what are the examples of applications. So like that, everything clearly mentioned in these PPTs. So I think in the end of this, I think today is the last session for me. So by the end of this particular session, if you want, we'll provide these particular PowerPoints for you. Okay. So here in the last, we have to, after filling up all your fields and all this, we have to save channel. And after that, we said you that in the program, we have to give the channel ID and we have to give the right API key. Okay, so where these are all available, where to see the data, just click on the private view. So where to see the graphs, where to note down the channel ID and right API key. Every step is clearly mentioned in the PPT. So if anyone is interested to go through it, so I'm asking that not only go through the IoT development kit, because that is may not be available for you after this workshop, but you can work on the any other like Node MCU generally available, and you can work on the ESP32, or you can work on the Raspberry Pi. So these are the three majorly used IoT kits for educational purpose. Like they will use something like these are open source. Like there is no restrictions. Only we have to use this. No restrictions like that. So that you can use your Node MCU, ESP32 or Raspberry Pi, and you can create the same ThinkSpeak account, and you can proceed through this particular cloud. Okay, so this is the how we have given the connections yesterday. Okay, so we connected that temperature sensor from here to there. Yesterday we have seen the program how to connect, and we have seen everything yesterday. Okay, right. So anyhow, finally we got the output like smart city environment monitoring, and just the graphs will be looks like this by clicking by taking your mouse onto this point. It will show what is the temperature and what is the date of the temperature. It will be stored over here. So everything you can able to see very clearly. Okay, so that is about a brief about yesterday's ThinkSpeak, how you have to log into ThinkSpeak and how you can send the values to the ThinkSpeak cloud. That is a we can call it as a some kind of academic cloud. But whenever you are into the field of IoT, there are some giant fields that is a big fishes in the market. So at least we have to know one of these big fishes to send data, how to send this data to the big fishes like AWS. Otherwise we have to know either Microsoft Azure, either we have to know IBM Bluemix, or either we have to know the Google Cloud Platform. So at least we should have to have a knowledge of at least one of these four. So then at least we can have some go for the real-time applications, so that these people are maintaining all the real-time cloud storage things. Okay, so let me start quickly. So what is this AWS cloud? So AWS cloud is the topmost commercial cloud with 175 cloud services. So it is having 175 cloud services. So in this particular 175 cloud, out of this 175 cloud services, we have 10 services for IoT. See, what is the meaning of this is AWS is not only for IoT. AWS is providing so many other things also. Only that this IoT is a small part of your your AWS. What is AWS? Amazon Web Services. So in Amazon Web Services, there are totally 175 services are available. So the services may be related to the artificial intelligence. It may be related to the machine learning, data visualization, big data, storage, otherwise OS related, like infrastructure related. So something like that. So many other services available over here. But out of this, we have 10 services available for the IoT applications. Okay, and this is the IoT core is the main service which is going to be used to store your data. So whatever the data that we are going to send from the sensors, whatever the data we are sending from the sensors to the cloud, so this will be reached to the IoT core in the AWS. So this IoT core is one of the main service for IoT purpose. So provided by AWS IoT devices. Okay, and this AWS is fully secured. So yesterday you have seen that ThinkSpeak is having only one MQTT API key. So if that MQTT API key is a number, so someone can able to crack it by some other method. But this AWS is not like that. It is fully secured. It will give one separate private key and a separate certificate for you to send your data. So without this private key and without these certificates, you are not able to send your data to the cloud. Okay, so that is a one advantage of AWS. It will fully secured. Okay, and next, it will also provide 1 year free trial. So for the people who are interesting to work on the AWS, they can create one account in the AWS, and they can go through the 1 year free service to use all its services. If you want to practice like because before buying your AWS cloud product, not product, services, before buying your AWS services, if you want to test how AWS service is suitable for my application, so if you want to test, you can create a 1 year free trial service, and you can make use of you can get familiar with all the services, and after 1 year, if you want you can drop the service, or if you want to continue the service, you can pay for the particular services. So that is, it is a pay as you go. It is a service called pay as you go. How much you are going to use, that much you are going to pay. Means it's like a same like your phone mobile recharge. How much you are recharge your mobile, that much you can able to make use of the internet data. Similarly here also, how much you are going to pay, that much you can use the services. So I want to you make use of 50 messages per day, then you have to pay only for 50 messages per day. So like that, how much you are going to use the service, that much you are going to pay the AWS. This is after 1 year, not before 1 year, it is after 1 year. If you want to continue the service, then you can go for the pay as you go service. And I already know, I said you that there are 175 services, broad category of services for data visualization. It is artificial intelligence, machine learning, big data, or data storage. So many other things are there. Again, it is a operating system. If you want any operating system also, they will provide the OS service, and they will provide the GPU service. For example, if you are I have a laptop with 8 GB only, but I want a processor with 32 GB. I want a very heavy processor. Then how you will get that processor? If you want to buy the processor, it means it is almost approximate 2 lakhs rupees. I don't want to spend that much of uh, uh, things on that particular OS, or otherwise GPU. So all these GPUs, all these operating systems will provided by the AWS virtually. You can create your own OS. Sorry, you can get your own OS in the AWS cloud. You can get your own GPUs facility in the AWS service. You can get your own application if you want have your application and you want to deploy that application. So you can deploy that application to AWS. So like that, there are so many things that are available in the AWS, and mainly it is very important that it is high speed content delivery. So within a second, your data is sent to the AWS. Yesterday I have observed that the ThinkSpeak is having a 15 seconds delay between one data to other data. ThinkSpeak is having a 15 seconds delay between one data to other data in the free service, whereas your AWS is having only 1 second delay between one data to another data in the free service. So that is one of the advantages. These are the advantages of AWS. One is the last but not the least one. It will allow you to send the alerts through email or messages. Today in our demo, we are going to see that how to send that emails and messages to the mobile or email. So like that, we'll see that service today. I will show you the demo. So through the demo, I will show how to create these alerts and how to get the alerts that I will show in the demo. So same like your earlier ThinkSpeak, I have created all the slides for you. So each and every step. So this is the first to enter into your AWS IoT. To enter into Amazon, you have to first type aws.amazon.com in the browser. Just open your browser and type it as aws.amazon.com. So here we'll get something called create free account. we'll get some icon over here. This is create free account. So as soon as you create you clicked on the create free account, it will ask few details for you. So it will ask your email address, it will ask your what password you want to put for your account, what is your email address, and confirm password, and then it will ask for your account name, what account name you want to maintain for your AWS. So after few details, click on the continue. Again, it will ask few more details, whether you want to use it for the personal purpose or professional purpose. Means, so initially we can use the personal purpose, because initially without testing the AWS, don't go for the professional purpose. So you should have some knowledge about the AWS, because this is fully commercial cloud. So we should not directly go for the professional one. Okay. So give your full name, you give your phone number, in which region you are, belongs to India, US, whatever it is, address, city, state, everything, every address we have to provide over here. So after these are all the things, that's what I'm saying. I provided the mobile number, I provided the country, address, city, state, postal code, everything I provided, and just click on the next option. So as soon as you click on the next option, it will ask for your credit and debit card numbers. See, this is very, very important for you. Credit and debit card number. So we should have to provide our debit card number to the AWS to create account. To create your free account, first of all, you have to provide your credit card or debit card details, its expiry date, its what is the name on the card, what is the name on the card, and all these details we have to provide, and we have to submit. So once you provide it, it will charge 2 rupees for you initially. Initially, it will charge rupees 2 for you, and once you enter the and you will get a OTP to the mobile, and once you enter the OTP and all these things are done. So once your account is created, done, your 2 rupees will you will get back that 2 rupees also. It will not charge the 2 rupees also for you. It is just for testing purpose, whether your debit card is proper debit card or it is a fake debit card. To find out whether your debit card is good or bad, it will charge 2 rupees for you, and then it will revert back everything. Okay, so this is a simple procedure that how you can create the account. There is a third verification step is there. First verification, you have to give all your details. Second step is you have to give your, first one is personal details, you have to give personal details, and second one you have to give credit card details, and third one you have to give your mobile details. You have to give a mobile verification, you have to do a mobile verification in the third one. Okay, so here this is my mobile number, and given some captcha over here, and just click on send SMS. Then I will get one 4-digit number on my mobile. I will get a 4-digit number on my mobile. So you have to enter that number here and just click on the continue. So this is the way how you can create your account in the AWS. So each and every step is mentioned very clearly over here. If anyone wants to create account, you can please go through these things and create your account. And don't forget, you have to choose your basic plan for free account. Don't go for the developer plan or business plan. These are not available for the free account. If you want to go through the free account, these two are not available. Definitely you have to go for the basic plan. Okay, so once you created the account, then you have to log in with your email ID. Okay, log in with your email ID and password. Okay, this is what a way how we can able to log into this particular cloud. Okay, so let's stop here. I think up to here, if anyone wants to try whether you want to create AWS account or all, so you can create over here by looking all these particular things. Okay, so this is the way how to create an account, because up to this particular thing, I don't want to show any practical way, because I already created the account. So I don't want to create any new account. So that's why I clearly given the steps here. So there are 3 steps you have to follow. First, create a free account, give your personal details, give your credit card details, and then do the mobile verification. So once this mobile verification and everything is done, choose the plan as basic plan and create the account. So once you create the account, you can sign in as usual. Just click on to the sign into the console and just click give your email ID and password. Where is this password is available? Initially we provided here. Here we provided the password. The same password you have to enter while you are logging at the second time. While you are logging at the second time, so you have to provide your username and password. Okay, so this is a way how you can create the account in the AWS and log into that particular thing. And again, after creating the account, what we have to do, so that we will discuss. But before discussing that, I want to go for the practical session directly. I want to open the AWS. I want to create everything in front of you. Okay. So, but before going to that, I want to show you that these are all the screenshots are available here, what to do, what not to do. So clearly everything is mentioned. So you have to search for the IoT core service, and then you have to go for the get started. Okay. And then you have to create a policy. Next, we have to create a policy. Why you have to create a policy? What is policy here? It is clearly given. Policy is something, and policy can allow a group of actions. So what are the actions we can have over here? So like that, in a PPT, each and everything I clearly mentioned over here. Okay, but anyhow, if something is there, means definitely we have to do some practical over here. So let me minimize this PPT over here. Okay, just I want to minimize this PPT over here. Okay, I want to just minimize this PPT over here, and I want to open my AWS and we'll go further. Okay, we'll go further. So right, if anyone is interested, you can please create your AWS account. So now whatever we are going to discuss, that is after creating the account. So I already discussed that how to create the account, but after creating the account, what we have to do. So that is we are going to discuss. So whenever you are going for any particular AWS account, you have to follow few steps. So what are those steps here? So number one, I will mention the steps for you. Okay. So what is the step one? First, we have to create, as soon as you are entering into the AWS, just log into the AWS management console. We can call it as management console. Don't forget this. We have to log into the AWS management console. So once you logged into that, the second step that you have to create is create a policy. So what is this policy here? So what we are doing actually with the cloud, what is the use of cloud? First of all, we have to store some sensor values into this particular cloud. Means in the cloud you want to send the data. That means you want to publish the data to the cloud, and also you want to subscribe the data to the cloud. Subscribe from the data, subscribe the to the cloud, so that whenever any data is available, that is sent to you back. Means from the cloud you can read the data from the cloud. That means a policy is a system which will define that what are the actions that you are going to do, whether you want to only publish the data to the cloud, or whether you want to only subscribe to the cloud so that you can receive the messages from the cloud. Otherwise you want to do both the things. I want to send the data, and as well as I want to receive the data. Whenever you want to do both the actions, so what type of actions you want to do with the cloud, so that we have to mention in the policy. So that is what call as why we have to create a policy, right? Once you create the policy that I want to do all the operations, like I want to do IoT colon star. What is this IoT colon star? Indicates that star is nothing but I want to do all operations. I don't want to do only publish. I don't want to do only subscribe. I want to do both publish, subscribe, delete, insert, everything I want to do. So for everything, we have to mention a star over here in the policy. Okay, we'll see that one. And what is the third step here? It is that create a thing. What is thing here? Yesterday, what you have created a channel in ThinkSpeak. So what is this channel in the ThinkSpeak? It is a place. Sorry, it is application name. What is channel in the yesterday's ThinkSpeak? Channel is an application name where we can able to store the data. Similarly, here also, thing is a application name where you can able to store your data with following policy conditions. This thing is going to be receive the information following the conditions of the policies. Okay, that is a one more. What is the step 4 is that, as you know that we have the AWS is very secure. So then how do you know that it is very secure? Means you have to download your certificates. You have to download your certificates clearly here. Okay, so you have to download your private key, whatever the private key is there. You have to download your private key and what thing certificate. So because as you know that AWS is providing the certificate, sorry, providing the security if you have these certificates with you. If you don't have these certificates with you, you are not able to communicate to the AWS securely. If you want to communicate, if you want to hold your data very securely, you have to download your certificates from the AWS. These certificates are available only once while you are creating the your thing. Then only the certificates will available. It will not available again and again. Okay, sir. I downloaded now, so that shall I get the certificates again and again? Means it's not possible. While you are creating the thing, it will available only once. You have to preserve very carefully these certificates. So once you lost the certificates, means you just forget about your thing. You have to create a new thing for you. This thing will be no more valuable. If you lost your certificates, this thing is no more valuable. Okay, so that is a very one of the important step of AWS. So once you download the certificates, then we have to okay, thing is created, certificates are downloaded. Then we can now test your note down some note down. We can call it as IoT endpoint. What is this IoT endpoint? Okay, what is this IoT endpoint means? Whenever you want to communicate to the AWS, how you will communicate? It's kind of address. It's kind of a address to your thing, address of your thing. So that is technically it is called as IoT endpoint. In the AWS, it is called as IoT endpoint. I will show you that how to create this IoT endpoint. Okay, once that is finished, we can test the service. So whether this is working or not, test the thing, whether it is receiving or sending and receiving, like thing is receiving the values or not, something like that. We can test the service. We can call it as test the service. Okay, and next step 7 is that set up events, like what we can call it as a rules. Rules means what do you mean by rules? Is that sending emails, messages, something like that. So what do you want to do some action, whether you want to sending an email, whether you want to send in messages, whether you want to create a data set, because we are getting some data. So what do you want to do with that data? I want to create a data set with the data. So that is nothing but IoT analytics. So I want to do some analytics. So all these things are called as a rules. So you have to create some rules. What do you want to do with your data? So whatever the data we are getting from the sensors, what do you want to do with the data? Whenever something happens, I want to send emails. For example, whenever temperature is more, I want to send a message. Okay, and I want to create the data set for the incoming data. I want to do some analytics. So whatever you want to do, you can create some rule for the whatever you want to do. Okay, so these are the seven different steps that we have to do in the AWS. So let us do these steps one by one. Okay, so next I'm going to open up my AWS over here. So what is the URL for AWS? So in the starting itself, I mentioned that. What is the URL of AWS? Anyone remember that? I don't think so. Okay, so anyhow, the URL is that aws.amazon.com. Okay, so now I entered into the Amazon aws.amazon.com. First, what I have to do? What is my step one here? As soon as I entered here, I want to log into AWS Management Console. This is my step one. I want to log into AWS Management Console. I already told you that if you have an alt, it's fine. If you don't have the account, so please create one account before going to these particular steps. Okay, but I'm starting with my steps here. So how to log into Management Console? So just click on this My Account. Okay, so if you want to create account, you can directly create. Click on the Create an AWS account. Otherwise, you can here we have a button called Get Started for free. You can just click on this Get Started for free if you want to create your account. Okay, already I have created my account, so I want to go for the step one. What is my step one? Log into AWS Management Console. Log into AWS Management Console. So I'm going for the step one here. So it's already logged in, but generally it will ask for the username and password. So let me log out from here. Okay, let me sign out here, and once again I want to show you the login page. Okay, just my account, AWS Management Console. This is a little bit longer process, so please be patient so that so this is my email ID. Sorry, this is my AWS account. Okay, I entered my AWS account, engineering@xtransolutions.com. This is my AWS account name. By clicking on the next, so it will ask for the password. Here, let me enter my password over here. So whoever created the account, after create the account, you have to log into Management Console. This is the first step. Okay, step one is finished. Okay, step one is finished. So what is my step two? I have to create a policy. So what is my step two here is that I have to create a policy. So before creating the policy, what is the service name that is available in the AWS? Earlier we discussed in the first slide of the AWS. What is that service name? IoT Core. This is the main service where we have to create our policy thing, everything, whatever we want to create, all these things, we have to create all these things in the service name called IoT Core. So how to search for that service? Here there is something called, you will find services. Just go for this search box and just click for IoT Core. So by searching for IoT Core, you will get some service over here. You can see, if you observe this, there are so many services here. See, you can see list. I said 175 services. These are the 175 services. You can see the list. So many services available. So these are all different 175 services which are available in the AWS. Okay, so I want to do only a 0.1% of this IoT, that is IoT Core. Okay, just click on this IoT Core. Okay, as soon as you click on the service called IoT Core, you will get a dashboard like this. Okay, so what is our next? First step is create policy. Okay, once you enter into the service, what is our step two? Create a policy. How to create policy here? So to create a policy, you have to see all these things are clearly mentioned in the PPT. Here I'm just showing the practical case here. So if anyone wants to try later, you can go through the PPT clearly. Okay. So here secure and policies. Already discussed that. What is this policy here? Policy is nothing but it is for example, this okay college is there, so the college wants to create some policies like I have my policy here. For example, I'm writing that smart city policy. So for smart city, I want to do some conditions. Otherwise, some other any name you can give for the policies. Okay, smart city policy. Any name you can give, and what are the actions that you want to do. Here you can mention that what are the actions you want to. I want to do IoT colon. See here, what are the actions? What are IoT publish, IoT subscribe, IoT connect, IoT receive, update, get thing shadow, delete thing shadow. So this many services, this many actions are available. So what actions you want to do? I want to do all actions. So that is nothing but IoT colon star. Star indicates that I want to do all the actions. Okay. And what is this resource URN? This resource URN is a unique policy name. For example, you created 20 policies. Then how to recognize your policy uniquely? So this kind of a ID, so to recognize your policy uniquely. But for particular demo purpose, I don't want to give any unique ID. I want to give it as a generic. Generic means I have to give a star. Star indicates that it is a generic policy. It's not having a unique ID. Okay. I have to make allow. Okay, I want to allow all these actions. Okay, I can deny also actions. Means, so for example, this particular policy, I want to deny only subscribe. Other than the subscription, other actions will be allowed. So I can just write IoT subscription and I will click on the deny. So that particular action is not possible. But here I'm clicking on the allow. Allow means all these actions are allowed. Star action. Star means publish, subscribe, connect, delete, update, everything is allowed. Okay, just create. Okay, my policy is created here. Smart city policy. My policy is created. Then what is the next step here? How to create a thing. So what is this thing? Thing is the place where actually we are going to store our data here. So where we are going to store our data, that is the place called thing. So let us go for that particular creating a thing. I'm sorry. My God, how many things are opened? Okay, so let us go for creating a thing. Policy is created. Step 2 is finished. Next, go for the step 3. So in the step 3, how to create a thing here? Go for the manage. Left hand side, we have something called manage and click on the things. So by clicking on these things, see, I have already created something called IIoT, ITTR, something that I have created over here. So you can create your own okay, your own policy or your own thing. For example, it is related to some college. Let us take I'm take like directly create. So let us create a new one. Okay, just click on the create. Right hand side we have a create, something like that. So in this again we have two types: create single thing, create many things. What do you mean by this? Single thing means it is a simple application. There is no linkages for the application. But there are some applications which are multiple things to do in a single environment. For example, college is there, so there are different departments are going to be available. So every department is having some application, but coming to the college, all the departments, they have to combine their actions and they have to do a college. It has to be shown as a college property. So then what happened here? Here multiple applications are going to be combined into a single representation. So that is called as a create many things. So like, but application is same, but you have to create a sub fields in the each and every application. So in that particular case, we'll go for the many things. But in my case, I want to create only single thing. Just go for a single thing. Okay, let us give some smart city thing. Okay, this is a thing that I'm creating that is related to smart city. So I'm just creating a smart city thing. Okay, I don't want to bother about any other things. Just give the name and click on next. So what I said earlier, whenever anything is created, it is automatically generate some certificates for you, which will provide the security for you. Okay, so now we are creating a thing called smart city thing. So I'm creating that certificate for these particular things. Just click on the create certificate. See, as soon as you create a certificate, AWS is providing few certificates for you. You have to download these certificates. These certificates not available for the further purpose. So you have to be very careful here while you are downloading your certificates. Don't forget to download these certificates. Without downloading the certificate, if you just proceed for the next step, you are finished. Your thing will not be worked out, because without this certificate and without this private key, whatever you are doing up to now is waste. Okay, so let's download the certificate. Okay, let's keep, and next download your private key. Okay, I did both. Private key and public key. No need to download the public key. Public key is same for all the things. So that is a public key is already maintained by the AWS. So we no need to maintain any public key. But there is something called root CA file. We have to download this root CA file. What is this root CA file? Is that it is a security file which is going to be vary for the different platforms. For example, in this case, I'm using the AWS for Raspberry Pi. So I'm using these certificates in the Raspberry Pi. So for Raspberry Pi, we have to download a different root CA file. For Windows file, we have to download a different root CA file. For Mac systems, we have to download a different root CA file. But that means that depends on that the device is using which type of security. Depending on that type of security, we have to download a respective CA files, root CA files. We can call it as root CA files. Okay. Of course, I have already I have my root CA file, so I don't want to download these files over here. So just I downloaded these two, and I'm just activating this. Okay, certificate is activated, thing is created, certificates are generated, and it is activated. All the three steps done successfully. Okay. Okay. So once it is activated, let me go back to my folder here, show in folder, and save these two files, because these are the two files are important for us. Where is the other file? 4B. Okay, let's copy this and then we'll go for the other one. Some new folder. I'm creating the folder. Save these particular things. Let us copy this. To paste these into some particular. I'm very sorry. Okay, I downloaded my private key and as well as certificate over here. Okay, so once this is finished, let us minimize this. And what is our next step? So create thing is finished, download certificates is finished. So all these things are finished. Then we have to finish that thing and all these things. So okay, we'll go for that one here. Okay, so once it is finished, if you go down, we have something called attach policy. See, whatever the policy and thing we created earlier, we have to attach this policy and thing to the certificate. Then only all the three will be in a synchronous. all the three will be in sync. If you are not attaching this policy, these certificates will not be work out. Okay, so let us attach a policy. So what is our policy? Smart city policy. Earlier I created smart city policy and then register thing. After attaching that, register the thing. So right, thing is created. So this one work is finished over here. So let's move back to the certificates here, where the certificates available, secure certificates here. So this is my certificate. You might have asked the question, sir, you said certificates are not available. So then what is this? This is only certificate. There is no private key in this. This is only certificate. Private key is not available for you. Okay. So what we have to do in this certificate, we have to go for this certificate and just click on activate. Okay, certificate is activated, and then click on three things we have to do here. One is we have to activate it. Second one is we have to attach policy. What is our policy? Smart city policy. Attach it. And also third thing is that we have to attach the thing. What is our thing? Earlier created smart city thing. Okay, attach it. Right. So what are the things that we activated the certificate, we attach the policy, and we attach the certificate. This is just for the clarification, confirmation. Why? Because earlier we already did all these things. So then you can ask why you are doing all these things again, means just for confirmation whether all the three are connected or not. I did once again here. I activated the certificate again. I attached the policy again, and I attached the thing to the certificate. So for all the certificate, we have to do these three things before going to the before sending the values to the AWS cloud. Okay. So right, what we have did up to now. So one more step is there. Step 5 is note down IoT endpoint. See, up to now we logged in, we create a policy, we create a thing, we download the certificates. If you want, we can have one more thing here. It is attach. We can write here attach policy and thing to certificate. These are the things that we did up to now. Okay. So now next step 5 is that note down the IoT endpoint. So let us go for that. Where is the IoT endpoint? My endpoint is, where is that my endpoint? Let's note down that. So let's close all these things. For that particular endpoint, you can go for the manage things. Okay, which thing you are related to? Smart city thing. Okay, so here you are something called interact. There is something called interact. So there is something called thesis. So anyone heard about the MQTT protocol? We have some broker address. So this is the address. This is the main address to send the values to this particular thing name, whatever the thing that we have created here. If you want to send any values to this thing, then we have to use this particular address. So let us copy this address, okay, and paste it somewhere here. So let us create one notepad over here and paste inside the notepad. Okay, let us take some text document. We can call it as a thing address. So what is the AWS thing address? It is, okay, just open a text box, text pad, and just save this, because all these things are useful for us while we are writing the program again. Okay, see, these are all the steps up to now we are doing only for writing all these things. Then we are going to have one more thing, is that we have to write the program, and then we'll come back to here. Okay, right. So this is the thing. And what is the next one? Next step is we have to test the service, whether this service is working or not. So we have to test this particular service. How to test this service? We have to go for here, and here we have something called test. If you observe this in the left hand side, we have something called test. Let us test here. Click on the test here. Okay, what is this test? Test is a MQTT client. So yesterday, as we discussed, that MQTT client should have a topic. Publisher and subscriber both are going to be talk to a topic. So let us subscribe to a topic here. Let us take some topic called home/IIoT. I have some topic called IIoT. You can take any topic. See, this topic may be related to your application, what you are doing. So I'm doing some home application. In that, I'm applying some IoT sensors. Okay. So like that, you can do, for example, home. In the home, you can have a room 1, room 2, room 3 service, room 4 service. So like that, these are all individual service names that we are giving here. So that is called topic here. Okay. I have given some topic over here, and I want to publish something to the topic. I want to publish hello AWS. Just I want to publish some message over here. So whenever we have publish some message over here, this will be appear here. Otherwise, there must be some error. Yes. See here something we are getting over here means if it is any error is there, it will be in a red color. If it is in a green color means that is allowable. So our service is, our test is successful. So if you did something mistake, then it will comes in the red color. So means in the earlier steps, if you forgot any one step also, it will give a red color over here. So here, what are the steps that we did up to now? Those are correct. Why? Because we got a green color. So testing is finished. Now let's move on to the programming part. Okay, and I will just try to explain the program, and then we will do the we'll see the results in the AWS cloud. So that is a complete today's sessions criteria is we have to connect some sensors to the Raspberry Pi, and we have to send that values to the AWS, and we have to get some mail or message. So that is complete demo. Today's demo purpose is okay. So let's close this, minimize this. Okay. So let me open my PPT back. Let me open my PPT back here. So let me maximize this. Okay, these are all the steps that whatever we did up to now. These are all the different steps that whatever we did up to now. See how to note down the key, how to move to these particular things, and all these things, everything I clearly mentioned in the here. So what is this broker address? This is our broker address. So here we are able to see this. So whatever the things that we noted down, IoT endpoint, that is our broker address. IoT endpoint, whatever we noted down, okay, that noted down the IoT endpoint is nothing but your broker address. Okay, this is what called as topic. What is the topic that we have taken something just before? Something called home/IIoT. Okay, so whatever you want to do in the MQTT, the sensors has to be write the information to a topic. Okay, the sensors has to be write the information to a topic. This topic is going to be provided by a broker address. So that is nothing but your IoT endpoint. Okay, so that is briefly what is MQTT here. So these are the few things that we have to download paho.mqtt.client. This is one library, one important library that we have to install in the Raspberry Pi before going to this MQTT application. Okay, this is your broker address. That's what just now we noted down, IoT endpoint. So this is what we can call it as REST API endpoint, or otherwise we can call it as a broker address. Okay, and the port number for this is 8883. So to communicate with this MQTT, we have to use the port number 8883. So 8883 port number we have to use to communicate to the MQTT over here. These are all Python programming part. So if you want, we can implement your JavaScript programming, or you can, if you want, you can implement your embedded C programming. But the concepts are same. You have to use some library. Here, instead of writing import, there we'll write hash include. If it is C language, what we'll write? Hash include paho-mqtt. Some library name we will write paho.mqtt.h. Okay, if it is C language, we'll import the libraries in a different way. And here it is a broker, means it is a string. We'll write a string broker equal to this, and int port equal to this, something like that. For language to language, the things will be changed. But this is a Python language, but the concepts are same. Okay, what we have to take, what we have to consider. Okay, we have to consider the broker address. We have to consider the port name, sorry, port number. And see, this is the place where I'm providing all my certificates and all these things. See, this is my root CA certificate. This is available in my Raspberry Pi system. And this is my CRT certificate that I downloaded earlier. And this is my key, private key I downloaded earlier. So all these three certificates names we have to provide over here, and that certificate should be available in the place where your program is written. For example, your program is written in a C drive. Your certificates also available should be available in the C drive. That's why I downloaded, and I will later I will shift it to the Raspberry Pi and all these things I will do. Okay. And already I told you that to communicate with the AWS MQTT cloud, we should require a topic name. This topic name will depends on your service, what services you are providing. So depending on your services, we have to give topic name over here. Okay, and also here I'm dumping all the values. What my values are JSON.dumps. I'm using some JSON format to write all this data. Okay, what is JSON format? Key value pair. It will be like a key value pair. What is my temperature is value is temp. Humidity value is humidity. Light status, the value is light status. So something like that. All these are variables that I'm reading from the sensors. This is sensor 1, sensor 2, sensor 3, sensor 4. All these things I'm reading from the different sensors. Okay, so I'm reading clearly from the different sensors. I'm sending these values to the publishing. And publishing means I'm sending the values to the AWS. Okay, so this is general coding structure. Okay, I don't want to discuss all these things again. See, this is my demo. That is what I want to discuss clearly. So what is my demo here is, so my demo is, it will use 5 different sensors over here. So one sensor here, it is a metal detector. How many of you know that this is industrial proximity sensor? How many of you know about this? It will detect the metals between 2 mm to 5 mm. Just imagine that 5 mm means very, 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 very near. So generally it is used in a machinery. For example, this is one machinery is there. This machine will have some hand to pick the, for example, this machine will have some hand and it has to pick some device. For example, let us take, it has to pick some metal device. So how this machine will know when I have to pick this particular metal. So then what happen here? Here we'll put a inductive. Sorry, just here we'll put the inductive sensor. Whatever the sensor is there, we will put the inductive sensor here. So as soon as here we have a belt. Here we have a belt here. So in the belt, all the metals are going to be there coming in a sequence. Metal 1, metal 2, metal 3. All the metals are coming in a sequence. So as soon as the metal comes nearby here, it will send the information to the machine. So that what happen here, this machine will comes here and pick this metal and throw it in some other place. It will place in some other place. So like that, after this, it will come. Next metal will come. So like that, all the metals which are coming in a sequence that will be detected by this particular metal detector. So this is the place. This is the application where we'll use this. Metal detectors are used in automatic automations in a machine in industrial automations. Also your bomb detector, for that also we can use this metal detector. So for like because for not all kind of bombs, it will not detect electronic bombs and all these things, but it can detect the kind of bombs which will have some metals inside the bomb. So like that, for that also we'll use this bomb metal detector and all. Okay, and I'm using second sensor, DST11. So yesterday itself we discussed about this. This DST11 is a temperature and humidity. So it will read this air temperature. So what is the temperature in the air? Means that is a general temperature in a environment. We can call it as a environment temperature. It will recognize the environment temperature. And the third one is LDR. Earlier we have seen that this is a light sensor. So it will recognize whether the environment light, so it is a daytime or night time. Okay, so daytime means we have a good light inside our room and inside our environment wherever we are working, there will be some good light. So whenever, as soon as it is dark, so it will recognize that it is a night time. So as soon as it is night time, what we can do, we can blow some bulbs, tube lights. So some lighting we can glow inside the room. So as soon as it is getting dark, we can switch on our lights and we can switch on our tube lights, and all these things we can switch on depending on this particular sensor only. Okay, so this is what called as LDR, light dependent resistor. Okay, and also I'm using one more sensor called gas detector. So what is this will do? It will just do the LPG gas detection, gas leakage. So it will detect the LPG gas. So in a room or in a factory or in any other gases whenever that are leakaged, so it can able to leakage only three things. Sorry, it can able to recognize only three things. One is LPG gas leakage. It can also detect the smoke. It can also detect the fire. So all these things can be detected by this particular gas sensor. So that is one I'm using. Last sensor, but not the least one. This is a very important one, that like liquid temperature sensor. So I can use this liquid temperature sensor to measure the temperature of any liquids. It may be a water, it may be a milk, maybe any other liquids. So what is the temperature of that particular liquids? We can able to recognize using this liquid temperature sensor. Okay, once I will able to read all this information to the of course here I'm using the IoT development kit. So in your case you can use either ESP32. I recommend this ESP32. Okay, and also you can use Raspberry Pi. So if you want to very easy indication and all these things, then you can use Raspberry Pi. Okay, RPI, they can call it as Raspberry Pi. Otherwise, in other case, we can use the Node MCU also. So any kit you can use, because we are available with the already we are available with so many things are inbuilt onto the kit. So I don't want to go for the much wiring and all these things. That's why I used this particular kit, which is already developed for me. Okay, the people who wants to develop their application, they can use any of these particular controllers. Once you connect all these things, we can send the information to the AWS. And then what AWS will do? AWS will generate some messages based on the what condition that you are applied for the AWS. So based on the what condition you are using here, so based on the condition, it will generate some messages. Otherwise, it will create a data set and it will give it to the deep learning, machine learning, neural networks. So whatever the application that you want to apply, you can give it. It can give it for the analysis purpose. So once these are analyzed, again the results can be sent back to the kit. So that if you want to start a motor, depending on some other analysis, if you want to switch on a AC, depending on your weather, so like that switching on that kind of actuator, we can call it as activating the actuators. So that activating the actuators will depends on these are all things we can do it from the cloud. Okay, so what condition means it will process the conditions. What condition that I have to do the actuator to be activate. So those are conditions are going to be processed in the cloud, inside the cloud. So this is my overall demo block diagram over here. Okay, so this is my real connections over here. So yesterday I'm not able to show you properly. That's why I have taken a photograph of these connections here, and I used all the sensors over here. You can observe that this is my liquid temperature. I have some water inside the glass. Okay, this is my metal detector. So I can put any metal like one coin. If I put one coin over here, it will able to detect the coin also. Okay, similarly I have a temperature and humidity sensor, which is switching on. And I have a light sensor, LDR. This is my LDR. This is my temperature and humidity sensor. And this is my gas sensor. Okay. So totally 5 sensors I'm using in this particular demo. One is temperature and humidity sensor. One is light sensor. One is a gas sensor. Another one is liquid temperature sensor. Another, other one is a liquid temperature sensor. Another one is metal detector. So these 5 sensors that I'm going to use in my demo. Right. So let me close this PPT over here. Let me enter into my Raspberry Pi, and let me show the coding part. Okay, let me show the coding part. I don't want to explain much coding here, but just I want to show what the code that I have written for in this particular thing, and after that we'll go for the demo. Let's open my Raspberry Pi here. By God's grace, it should not be repeated the yesterday's action. Okay, thank you. Okay, right. I'm successfully able to log into this particular Raspberry Pi over here. Okay, and this is my code. I hope you are able to see my screen. Can anyone answer? You are able to see my screen?
Yes, sir. It is visible, sir.
Okay, thank you. So here, of course, this program is having so many number of sensors. So the program is having a little bit longer, but I want to just quickly, just within 5 minutes, I want to explain what are the libraries that I have used and how to write the logic and all these things. So here I'm using something called OS and glob. So these are the two things which are used to work with the liquid temperature sensor. What is this liquid temperature sensor? Is a one-wire technology. Yesterday I told you that there is something called one-wire technology which is having some storage inside the file. So to deal with the files, we have to import the OS library, because this liquid temperature sensor is going to have a one-wire technology. This one-wire technology will generate a value in the file. So to read that file, we have to go for the OS. And similarly, yesterday we have seen that Adafruit underscore DHT for reading the temperature and humidity. Yesterday we already seen that. And this MCP3008 is a library which is used to read the analog value. So which is analog value here is that our gas value. Whatever the gas sensor that we are using, that is an analog sensor. So to read that analog sensor, we should have to use the MCP3008. What is this MCP3008? This is a ADC. What is this ADC IC? It will convert the digital value, analog value into digital value. It will convert the analog value into digital value. So that MCP we have to use. Why we have to use this ADC chip in the Raspberry Pi means Raspberry Pi doesn't have any ADC pins. We have to, if you want to use any analog sensors, because my gas sensor is analog sensor, I'm not able to connect directly. I have to connect ADC called MCP3008, and through this ADC only I can connect to the Raspberry Pi. Okay. And also this MCP is a SPI protocol. Yesterday I told you that so many things are connected with so many hardware protocols. Here also I'm using a SPI protocol. And also I'm using a GPIO protocols. What are the GPIO protocols here? Your light sensor is GPIO protocol. Okay. Your metal detector is a GPIO protocol. I said, most of the sensors, in the 80% are from GPIO only. Okay. So this is GPIO sensor, metal detector, and also one more sensor is missing. We are using DHT here. Okay. Gas sensor, DHT, light sensor, metal detector, liquid temperature, right? Everything is covered, all the 5 sensors of different libraries. Then what is this? So whenever you want to send this data to the cloud, so this library we have to use to send the data to the cloud over here. Okay, so this is the library to install the cloud. This is for, again, for security purpose. See, because you are providing the certificates. So it will not directly take the certificates. You have to import the library called SSN, and then you have to import your library. Sorry, import your certificates. And similarly, there is something called JSON. What is this JSON? Data format. So if you want to provide the data in a key value pair, you have to give this JSON format. Okay. So these are different libraries, and quickly I want to go through this. See, this is my light is connected to LER is connected to 33, proximity is connected to pin number 37, and your DST is connected to pin number 17, and proximity is connected to pin number 4, something like that. Everything is connected over here, and we are writing some logics to read that. And this is my IoT endpoint. Just before we discussed that, what is this broker? Broker is nothing but your IoT endpoint, which I have noted down earlier. Okay, remember that I noted down earlier. So that IoT endpoint is this. Okay. Similarly, the port number is 8883. I earlier discussed that the port number should be 8883. And these are my certificates. This is my certificate, root CA for certificate. This is my CRT certificate. This is my private key certificate. So like that, 3 certificates I need. So all these 3 certificates, I can show you that here. For example, in the desktop, if you go for the desktop, see this is my key, private key certificate. This is my device certificate, and this is my root CA certificate. Okay, you can observe this one, and this one. These 3 certificates I copied into my Raspberry Pi from the Windows desktop. Okay, so don't ask me how you copied it. I used some other tool to copy from that to Raspberry Pi. Okay, you can use that tool, or otherwise you can directly copy paste also. So don't worry about the copy pasting at this particular time. But you have to copy all these certificates into your place where your program is existing. This is my program. So where my program is existing, along with my program, I have to copy all these certificates clearly. Okay, I mentioned all the certificate names over here. Okay, I mentioned all the certificate names over here. Okay, this is my topic. Every time I'm saying that we should have to send the values to some topic. Directly we can't able to send the values. So this is my topic, and comes to end. These are the logic to read the values and all these things. Okay, this is the place where I'm sending all the values. Liquid temperature. Okay, I'm sending the value of liquid temperature, air temperature. Okay, light status, gas value, proximity status means whether metal is there or not, proximity status, and what is the today's date. So along with the date, it will send all these values to the cloud. Okay, so this is what the things going to be written in the programming side. Don't worry about the programming side. The people can get habituated to write the programming one by one. It's not like one simple day or in one single hour. We can't understand all this program, and we can't able to write these things. So okay, for this you need some practice over here. But anyhow, I explained what are the things that I used in my program. Let's run this program. Before running this program, this is my Raspberry Pi actually. So I'm opening the Raspberry Pi here and go for my AWS account. This is my AWS account. Okay, so let's open my service like IoT core. What is my service here? IoT core. So let's remove all these things, and I want to open IoT core. Yeah, this is my service IoT core. Why I'm opening all these things? Because if you want to see the data on the AWS, you have to go for the test purpose. Sorry, you have to go for the test. You have to go for the test, and you have to subscribe to a topic. So what is our topic? I'm writing in the program. I'm writing one topic. What is that topic? Here it is home/. So earlier I mentioned one topic. What is my topic here? home/IIoT. This topic you have to write in the test part. So home/IoT and subscribe to that particular topic. Already we are subscribed. Don't worry about it. Already we are subscribed. So now if you run the program, you have to get the data here. In this place, you have to get the data. Then our program is successful. So let's run the program here. Let's go back to this. Where is that? Yeah. So let me run the program here. Click. Yeah, you can able to see the console here. Liquid temperature is 24 degrees. Okay, my air temperature is 26 degrees. I already told you that my liquid temperature sensor is there in the glass where some water is there. So this is water temperature. So water is at a temperature of 24.062 and air is at a temperature of 26 and all these things. Okay, so let's move on to our cloud here. See, I'm getting the values. This is a 24.062 earlier value, and also I got one more second value also. All these values I got here. Okay, so let me close this, otherwise I will get the messages because I have alert over here. So let me close this here because I written some alert. I'm getting continuous messages over here. Okay, right. So right now you are seeing that what is that, what are the values that we are sending from the sensors. I'm getting all these values. So what is the 6:47? The time is at one is at 4:47 and one is at 4:47 36 seconds and one is at 4:47 52 seconds. So something like that. Different timings will get the different values over here. Okay, so this is how we send the information to the cloud. And the last but not the least, we want to see how to send the messages and mails. Okay, so for that particular purpose, we'll have something called service called SNS. What is SNS? Simple Notification Service. Okay, we have a service called SNS, Simple Notification Service. So in the Simple Notification Service, we have to subscribe for our mobile number or mail ID, whatever you want to go for. So let us go for the subscriptions. I have one subscription over here. So let us go for this one. So if anyone wants to see the message, let me edit this. This is my topic, IIoT topic. Okay, here I have a mail ID. I want to create one more subscription. I want to add one more mobile number. If anyone, please provide your mobile number so that once I run this, you will get the SMS for your mobile. Can anyone provide the mobile number quickly? So we have only 10 minutes of time. Can anyone provide your mobile number here so that I will add your mobile number here. So as soon as I execute the program, you have to get some message alert for you. Anyone, any volunteer, please provide your mobile number. Any volunteer? No one? No one wants to provide your mobile number? At least provide your mail ID. Anyone please provide your mail ID? Okay, I got one mobile number. Thanks, Prasad. Prasad said thank you. Okay, I'm just copying this and I'm just pasting over here. I'm just add a +91 our India code here. I'm just adding +91 over here. Okay, and I just want to create the subscription. Okay, so now I created the subscription over here. And what is my condition? Let me see the condition also. For seeing the conditions, again we have to go for the IoT core. Okay, I have to go for the IoT core. In the IoT core, we have something called rules. Earlier we spoke about this particular thing, rules. Earlier we spoke about these rules. So I created some rule called IoT alert rule. What is the condition here is that whenever the liquid temperature is less than 27 degrees centigrade, I want to get the alert. Okay, whenever liquid temperature is less than 27 degrees, I have to get a alert. This is what condition that I have written. whenever I got some message to this topic home/IIoT, within the message, if my liquid temperature is less than 27 degrees, then I have to get a message. So let's run the program once again and let's see that whether sir will get the message or not. So let's go back to the message over here. Sorry, go back to the Raspberry Pi and run the program once again, so that this time sir has to get the message. I think it may take just 1 minute time. I think by this time sir has to got the message. Sir, can you please confirm in the chat box whether you got any message or not? Prasad sir. No, till now you didn't get the message. I think it is a network delay might be. Because I got the message because parallelly I have both our numbers. My number is there and your number is there. So I got the message here. So I can, if you want, I can show this message over for you. So let me. I think I can go further. Any desk. Let me show you my message over here so that you will understand that. Okay, so let me show my message over here. I think, let me go for the messages. Are you able to see my message over now? Here it is.
Sir.
Yeah. See here clearly, IIoT topic and liquid temperature here. It is 24.062 air temperature. All these things I'm getting as a alert. So as soon as I'm getting this, I will get a alert over here. I think there might be some network issue or there might be some delay for your mobile. We can try that also. Okay. So let me stop my program here. I think I already stopped my program. Yeah, that's fine. So this is what I want to show you from end to end. So whatever the things from starting from AWS, how to create the account, how to create a policy, how to create a thing, and then how to note down that downloading the certificates. And after that, we have to note down the IoT endpoint. And then we have seen that demo, what are the different sensors that we used in the demo. And also we have seen that how to create an alert over the AWS and all these things. And definitely I think sir will get the message after some time. We can confirm that one also. Okay. So with this, I want to end up my session over here. And I want to take last 5 minutes are there. I want to take some questions from the participants for the last 5 minutes. Otherwise, you can ask any other general questions also regarding IoT. If you have any general issues, which controller to use, which sensor to use, if you have any ideas of application, you can ask any other questions regarding these particular things. Okay, so from my side, this is the thing that I want to give, that I want to show in this particular session. So Naman sir, I think it's time to take some questions.
Yes, sir. Definitely, sir. If anyone want to ask, so one can go ahead. One can ask any query related to IoT to the sir. Or else you can later on, if you have, then you can send to me. I will definitely send your query to sir. So if you want to ask, then you can. Otherwise, you may ask later on also.
Okay. So what is there is one question. What is mean by liquid temperature sensor? It's not actually. It's not liquid temperature sensor. The sensor name is DS18B. DS18B 20. That is a sensor name. Actually, I'm typing here DS18B20. Actually, this is used to measure any temperature of any liquids like milk, water, or otherwise any chemical temperature. For example, in the industry, they will use so many chemicals. So that chemicals has to be heat for the particular temperature only. So something like that, we can use this sensor for measuring the temperature of that particular liquid form of device. Sorry, materials. That's why it is generally I'm using it as a liquid temperature. But the actual name of the temperature is DS18B20. Okay. Any other questions?
So thank you very much, sir.
Okay,
Thank you
sir.
very much. If one will be having any question, then I will definitely send to you. If one asks ask any query related to your talk,
Yes,
so
sir. Sure, sure.
I will definitely mail you, sir. So
Okay, sir, sure.
thank you very much, sir, for your kind, knowledgeable lecture, and
Okay.
definitely it will give motivate all the participants to do work in the field of IoT. So thank you very much, sir.
Thank you for all the participants.
So all the dear participants, there is one more announcement. From tomorrow onwards, you will have to just click on the link, and also you just have to enter the passcode also. So the passcode I will just share through the email as well as on WhatsApp group. So from tomorrow onwards, you will just have to use your passcode to enter the meeting. Okay. So the feedback form for today's session, I will just share through mail or through WhatsApp group. So all of you just kindly fill that form. And also remember that from tomorrow onwards, you just have to use your passcode also. Okay, thank you very much. Thank you very much. Have a nice day. Thank you.